In this example, let's let f of x equal 5x squared, and g of x is equal to 1 divided by x minus 4. And we've got a third function, h of x is equal to x plus 6. Let's find the domain of f plus h to start with in part A. Let's make some room here. Let's find the domain of f plus h. Okay, so again, to focus your attention, f is here, 5x squared. H is here, x plus 6. So notice what I'm not doing. I'm not asking you to add these together. It would be easy enough to add them together, right? There's no like terms, so if you added them together, you'd get 5x squared plus x plus 6. But I'm not doing that. I'm asking you, what's the domain of f plus h? If you were to add them together, what are you allowed to plug in? Well, if you take a look at the function f of x, it's 5x squared. Is there anything you can't plug into 5x squared? So think about if you're not sure about how to find the domain of something, I guess you could graph it, right? Another way to think about it is, what am I allowed to plug in? If that doesn't do you any good, think about it in the opposite way. What am I not allowed to plug in? So for f of x is equal to 5x squared. Is there any number in the world, any real number that you can't plug in for x squared and multiply by 5? Think about it. Couldn't you do that with any number? So that means the domain for f is what? All reals. Any number can be plugged in. You can square any number. You can multiply the square of any number by 5. So any number can go in there, which means the domain of f, we'll call it dom f, is all reals. What about h of x? H of x is equal to x plus 6. Is there any number you can't add 6 to? Same kind of logic. What can't you plug in? Is there anything you can't add 6 to? I think you can add 6 to any number you want to. So what about the domain of h? The domain of h is all reals. So is anything bad going to happen when the domain of both functions is all reals and you add them together? How could anything bad happen, right? You can add any numbers you want, right? So that's a way to think about it. So it's all reals. Now, if you want to go ahead and find f plus g of x, kind of a generic formula for it, you can think of it that way too. So f plus g of x is equal to f of x plus g of x, which is 5x squared plus x plus 6. It's pretty clear you can plug any x value you want in there. Those operations can be done on any x value. That's another way to think about it. Does that make sense? So all reals. That's the domain. So I'm running a little low on time. So obviously I won't write anything down for part B, but hopefully it's clear. If you take f, which was 5x squared, I guess I lied. I'm going to write a little something down. If you take f, which is 5x squared, and you divide it by h, which is x plus 6, what is the problem child going to be, you guys? What input's going to cause a real trouble here? No, 0 is fine because you get 6 in the denominator if you plug in 0 for x. Negative 6 is the problem child. So the domain would be all reals except negative 6, right? So what's the way to write that? The domain would be the set of all x such that the shorthand would be x does not equal negative 6. If you didn't recognize what the problem child is, set the denominator equal to 0 and solve. And immediately you see the x value that x can't be. Let me go ahead and do f times g. Okay, f times g, guys. Remember, f is 5x squared. So think about f times g of x. Remember, that breaks down to f of x times g of x by definition. And f of x is 5x squared. And g of x is 1 over x minus 4. So if you multiply straight across, you actually get 5x squared times 1 on top, or just 5x squared divided by 1 times x minus 4 on the bottom. Is it obvious what the problem child is here? 4. So it'll be the set of all x such that x does not equal 4. And when you write that, you're assuming that x is real, right? When you don't specify that x is real, we assume it. Does that make sense? Okay, that's what you're up against today. I will see you next time, you guys.